The broadcast is now starting. All attendees are in listen-only mode.
So welcome to the third IEA webinar on modernizing energy efficiency through digitalization. I'm Vida Rosita from the IEA Energy Efficiency Division, and I'll be your moderator for this webinar. Today we'll hear from our Head of Energy Efficiency Division, Brian Motherway, who will provide a brief update on our work on digitalization. And then we'll hear from Stephen Beletic from the IEA Technology Collaboration Program on Energy Efficient End-Use Equipment, 4E, Electronic Devices and Networks Annex, EDNA, who will share some insights on the important role connected devices play in an increasingly digitalized energy system. I'll also take this opportunity to advertise our upcoming webinar, which will be already on the 25th of September, with the intriguing title, Light Bulbs or Cables, where we will have guest speakers from Scotland sharing insights and experiences in the role of digitalization and energy efficiency in managing electricity networks. Before I hand over to our speakers, some brief practical information. If you want to ask a question, make a comment, suggest a future topic which you would like to hear more about in future webinars, please use the question box. We will have a question and answer session at the end of the webinar. And now it's my pleasure to hand over to Brian Motherway, Head of the Energy Efficiency Division at the IEA, who's right here next to me, looking almost as relaxed as he is in this photo. Please, Brian.
Vida, thank you very much. And hello to you all from various parts of the world. If you're in our time zone, I would say good afternoon, and I'm sure you're in many other time zones as well. So we're very pleased so many of you have chosen to join us today for this webinar, which I think is going to be fascinating. And I'd like to thank Stephen very much for agreeing to speak about this important topic. Some of you will know that this is part of a series of webinars, as Vida has said, we are holding at the moment on the topic modernizing energy efficiency through digitalization. And we are holding this webinar series as part of a wider set of activities focused on the question as to how emerging digital technologies and all of the innovation and exciting developments that are coming will change energy efficiency, and in particular create opportunities for new types of efficiency to emerge, for more systems thinking and grid optimization, and just for maximizing how we use all of our devices and technologies and how that can altogether enhance the global energy efficiency opportunity. There are many promising technologies and many promises being made by technologies, but of course how they will work in practice is complex and uncertain, and it raises many questions for businesses and governments alike. And it is these kind of questions we want to explore in this work we are doing, including through these webinars. And I would refer to you, as you can see on screen here, we have some resources available to you on our website at iea.org. You can find all of our work on digitalization, including some case studies we published recently, as well as records of previous webinars, other events, and other publications. And I would also let you know that in just a few weeks' time, we will publish our flagship annual energy efficiency report, Energy Efficiency 2018-2019, and it will have a special feature on digitalization. So in our Energy Efficiency 2019 report, we will look at a number of angles of what digitalization means for energy efficiency and for energy demand as a whole. First of all, we'll explore some of the questions that are on many people's minds as to in what ways might digitalization and emerging technologies add to energy use through, for instance, greater energy use by data centers, devices, technology, things like that. Also, how might they drive demand up by making, for instance, car traffic transport journeys simpler, or tempting us to use more devices more of the time, things like that. But of course, there are many opportunities for how this technology might also push downward on demand trends and create energy efficiency opportunities, such as optimizing energy use in homes or offices, automating production, bringing new optimization to grids so that clean, cheap resources are used when they're available. Efficiency is applied in a more timely and subtle manner in terms of how we use it and how we get the most out of it. So there are many dimensions to this. We'll explore them in our report. We'll look at some case studies from around the world where these technologies are being deployed, and we will see what they tell us about these questions. And we'll also publish some new work on how policymakers may want to think about their responses and the kind of issues that policymakers and regulators should be looking at if they want to be fully ready for maximizing the benefits of digital energy efficiency and minimizing the risks and disbenefits. So this is very much part of an ongoing conversation. We always want to hear from you, so do please contact us via our website as usual. Do please engage with us via these webinars and other events that we are holding, and we hope that this ongoing conversation can continue on this very important issue. So I do hope you enjoyed today's webinar.
Thank you very much, Brian. And now, before I hand over to Steve, I'll just take the opportunity to answer one of the questions that we've received. Yes, the webinar will be recorded, and the webinar and the presentation will be available online shortly after this webinar. That said, please do try and stay with us and participate in our question and answer session. And now it's my pleasure to hand over to Steve Beletic.
Thank you, Vida, and thank you, Brian and the IEA, for the opportunity to present this webinar, which is about the key role of internet-connected devices in the digital energy system. Next slide, please, Vida. So before I get into the detail, just for a little bit of context, this is a slide or graph with a logarithmic scale, and what it shows is it's supposed to show the number of IP addresses, and IP addresses are the internet protocol addresses that each device needs to exist on the internet. And each device needs a unique IP address. It's a number. And in the previous version of the internet protocol, there were 4 billion IP addresses. And the engineers that designed the internet realized pretty quickly that 4 billion wasn't going to be enough internet addresses. So they thought, well, we need to, with the next version of the Internet Protocol suite, we need to provide some more addresses. So when they went to Internet Protocol version 6, they allowed for 3 times 10 to the 38 Internet Protocol addresses. In other words, a 3 with 38 zeros after it, and that's the green bar there on the right-hand side. And that's sort of more than the number of grains of sand on Earth, and it's sort of approaching the number of atoms on Earth. These are the available Internet Protocol addresses for devices. So this is really the reason that we care about policies and making policies in this area, that it is possible that in the future there'll be a very large amount of devices connected to the internet. This is the sort of context we're talking about. Next slide, please, Vida. So to introduce the subject for today and Edna. EDNA is well, as Vida said, it stands for the Electronic Devices and Networks Annex. It is an annex of the IEA's 4E TCP, the TCP on energy efficient end use equipment. And EDNA is focused on policy guidance for energy efficiency, particularly for connected devices and also the systems in which they operate. So connected devices meaning internet connected devices. And we have 12 member countries who get together to develop this policy guidance, which they then take back to their countries and use. And I am the operating agent for the annex. I convene the activities of the annex. Next slide, please, Vida. Contents for today. Firstly, what is a connected device? Why is a device so important? Why does connecting devices to the internet have profound implications for energy use? And why aren't connected devices delivering the optimum benefits promised? And then what needs to happen to try and realize those benefits in a fuller way. Next slide, please. But the first question is, what is a connected device or an internet connected device? And these devices, next slide please, operate on a continuum. So when I say devices, I mean appliances and equipment, white goods, water heaters, electronics, televisions, HVAC systems, lights, etc. All the kinds of appliances and equipment you might imagine that use energy, as well as sensors and thermostats and switches and things like that. So it's almost all electrical devices, particularly those that are manufactured, you know, and roll off a production line, and we buy them and install them in our homes and businesses. So devices at one end of the continuum, dumb devices. You know, a light globe is a good example. It is switched on and off by a light switch, and it is not connected to anything via a communications network, and it doesn't do anything smart at all. Next slide, slide 13, please. If we connect that device to a communications network, it can receive inputs via an external network. For example, the light globe can receive inputs from your smartphone. You can switch it on and off, change the color, change the output, dim the light globe, etc. So that's a connected device. Next slide, a smart connected device is something which has a bit of intelligence, and that intelligence allows that device to take independent action. So, for example, you can buy a light globe that allows, when you are watching TV and watching your football team play and your team scores a goal, and that light globe can flash the team colours. It takes an independent action, something which is kind of cool, but there's no energy savings associated with that action. Which brings us to our next slide, slide 15, which is an energy saving smart connected device. It can take independent actions to save energy. And there are two realms of that. The first one is to operate more efficiently, and we call that intelligent efficiency. A good example of that, of course, is when you leave the house and your smartphone leaves the house, the light globe can switch off. That's a sort of independent operation to save energy. And the other realm is demand flexibility. So that light globe can be controlled by the grid. At times of limited power generation, the light globe can dim down, and we call that demand flexibility. So that is the sort of the true energy saving smart connected device that can undertake those kinds of energy saving independent actions. Next slide, please, Vita. So this is so you remember that all connected devices are not necessarily smart, and smart does not necessarily mean energy savings. Next slide, please, Vita. So the second question is, why is the device so important in the realms of energy saving, intelligent efficiency, and also demand flexibility? Next slide, please. Well, first of all, devices consume more than 50% of the world's electricity. I'm talking about the kinds of devices that you buy off the shelf. And this is a chart here of electricity consumption over time for the world. As you can imagine, devices in the residential sector, most residential electricity is used by appliances and equipment, and probably a good proportion of electricity used in industrial and commercial sectors are also by off-the-shelf kinds of devices that you can buy. In industrial sector, maybe there's some bespoke industrial systems and processes which are not off-the-shelf devices. These are more systems designed by engineers to do certain processes, but certainly conservatively, more than half the world's electricity is used by appliances and equipment or devices. Slide 19. And the opportunity here is that many devices now are being sold to be connected to the internet. The sales of connected devices is increasing, and this is a graph here of the projected stock of connected devices. You can see by 2030, there's predicted to be almost 50 billion connected devices installed. That's around 6 per person. And that presents a great opportunity to do the kinds of energy savings actions that I alluded to. And we'll talk more about those a bit later on. So why, next slide please, Vita, why does connecting devices to the internet have profound implications for energy? There's really 3 parts to that answer. The first is what I alluded to, which we call intelligent efficiency. This is about adaptive, autonomous control of systems of connected devices, leading to energy savings. For example, the control of lighting and HVAC systems based on sensors for occupancy, temperature, and so on. But this is not just a building management system. This system is intelligent. It can optimize lighting and HVAC systems and also learn about the best ways to save energy. It uses sophisticated adaptive algorithms. It can even use artificial intelligence. All of this are aimed at saving energy inside that building. That's an example of a sort of commercial building situation. Next slide, please. An example in a residential scene, and again, a sort of a smaller scale here is a smart thermostat. Now, smart thermostats now are widely available. And these can collect occupancy information and apply sophisticated algorithms to control heating and cooling in order to save energy. And those are the kind of things we can buy now, and they do use very clever algorithms that are held in the cloud, and they can learn about the best ways to save energy in a house for the heating and cooling system. Next slide, please, slide 23. This is a very zooming out to a very, very broad example, a smart city. A smart city is a system of systems. For example, smart transportation systems, smart buildings, and smart grids. These systems are interconnected, and data from one system can influence the operation of another. To use quite a simple, understandable example, rubbish bin sensors can tell the garbage trucks when it's time to collect the bins because they're full. But from the traffic system, traffic sensors can also tell the garbage trucks that now is not the best time to travel to the bins because there's a lot of traffic. So that's a fairly simple example of systems talking to other systems within a smart city to save energy. Next slide, please. In the residential sector, and a lot of this presentation talks about the residential sector because it is easy to understand for us, but the kinds of opportunities that we see in households also apply to commercial, industrial, and other sectors as well. I won't go through this slide in detail, but you can see that some of the savings ranges in the right-hand column of what kinds of savings are available for cooling and heating and lighting and window control, etc. I'll leave you to peruse those numbers, but suffice to say there is a significant opportunity in all sectors to use intelligent efficiency to save energy. Next slide, please. The second part of the answer as to why connected devices have profound implications for energy use is what I talked about a bit before, which is demand flexibility. It's the ability of devices to respond to the variable electricity generation patterns of renewable energy sources, such as wind and solar. At times of low generation, no sun and wind, it is better if devices do not operate or operate in a lower power mode. At times of high generation, lots of sun and wind, it is better if devices do operate. That's fairly straightforward. And there are lots of examples, next slide please, there are lots of examples of these kinds of initiatives running around the world. And this is one from my home country, Australia, run by a utility called Energex. Utility can set the air conditioners that are connected to it using a power line carrier. The utility can set those air conditioners to economy mode during peak events, and customers are paid for that, for providing that service. That's just one example, and there are many other examples in California and other US states and elsewhere around the world. However, this kind of demand flexibility system is not ubiquitous. There's a long way to go before these kinds of connected devices can really respond fully to the kinds of power generation patterns provided by renewables. And the next slide is a very large example of the kinds of potential that's available, and this is in China. And this is a graph, a sort of 24-hour graph of cooling demand for China. The black line represents what is predicted to be or projected to be possible from using smart connected cooling systems. You can see there from the peaks on the purple line at the top of the screen, you can see there the kinds of peaks that exist, and that load curve can be flattened if smart connected devices are used. So we're talking hundreds of gigawatts of generation being sort of flattened out here. That's China. So next slide, please, Vita. That's demand flexibility. I'm sure you understand what that is. It brings me to the third aspect of energy as it pertains to connected devices, and that's the energy cost of connectivity. So this is a little different. This is not an opportunity. This is a problem that needs to be managed. And it exists because devices use energy to stay connected, even when they're in the off state. As you can see in this picture, this is a light globe. I've sort of cropped out the light globe so you can't see the brand. But this is a light globe in the off state, and you can see from the power meter it's drawing almost 3 watts. That 3 watts is being drawn just to maintain its connection to the internet, even when off. So as you can imagine, a typical ordinary dumb light bulb, when it was off 0 watts. But this one here is drawing 3 watts when off, around the clock. So this we call the energy cost of connected devices, and it needs to be carefully managed so it doesn't get out of hand, as it would with that light globe example, if that sort of technology was deployed in all connected devices. Next slide, please, Vita, slide 29. So this is a graph from one of Edna's reports, actually, showing the projected energy consumption, the energy cost of connectivity for connected devices out to 2030. And there are 3 aspects to that. There are 3 layers in that chart there. There's what we call network standby. That's the orange layer in the middle. That's the energy used by that light globe in that example when the light globe is off. We call that network standby, the energy used when the product's in standby. The blue band at the bottom is network active. So that's when the product is actively communicating with the network or with the internet, the energy used. And the top grey band is the upstream energy. This is the energy used not by the device itself, but by data transmission networks and data centers and so on. This is the energy used in the network upstream of the device that's caused by the device. So we add all those together, and we can see projected energy use here in 2030 of around about 1,000 terawatt hours per annum. And that's to put it in context, that's double the energy consumption of Germany by 2030. So that's the kind of scenario we need to be aware of and make sure that that's managed so that devices use as little energy as possible to connect, as well as have minimal implications upstream in the data centers and data transmission networks. Okay, so moving away from that energy cost now, back to sort of opportunities. And to answer the question, why aren't connected devices delivering optimum energy benefits? They are, of course, delivering some benefits, but nowhere near their potential. So we've sort of, in some of our reports in Edna, we've tried to look at this and to try and figure out how we as policymakers can increase the not only the uptake of connected devices, but also to make sure that they're used in the right way to save energy in an intelligent way, and also to participate in demand flexibility. Next slide. Again, staying with the residential example, this is a picture of an energy efficient smart home. It has many connected devices, lights, heating and cooling, water heating, appliances. There are sensors, perhaps there's a solar PV system, a battery, and perhaps even an electric vehicle. It's quite a complex beast, as you can see, which sort of starts to answer our question as to why this kind of system is not being taken up on a broad scale at houses. There are, of course, a number of barriers. Next slide, please. The first fits under the heading of consumer perceptions. We think that people don't really believe the benefits that will be forthcoming from connected devices, the energy savings and the functionality and the comfort that's promised. People don't really believe that those are going to happen. There's a very new area and very new technologies. They're perhaps not interested or don't really know about smart homes. And also importantly, they may be concerned about their privacy, the use of the data that's collected elsewhere, and also security concerns. You know, these devices being hacked and hackers gaining access to their home computer networks. Next slide. The next sort of heading for barriers is complexity and technology risk. As I said, these devices are new and inherently complex. They can be difficult to operate, and they also can suffer from a lack of interoperability. If I have appliances of different brands and they all use a different smartphone app to operate, and I can't get them all to operate together, I can't just have one simple interface to operate these devices, then that's a problem for consumers being engaged in this kind of intelligent efficiency and also demand flexibility area. Next slide. The third sort of area of barriers, I've put under the heading of business models. Business models that can provide or can address high initial consumer costs, a lack of ongoing consumer participation, and also a sort of lack of commercial incentive from different parts of the supply chain. This is also an area which needs some attention. Which brings me to my next slide, which is what needs to happen to address these three areas. Next slide, please. And before getting into each of the three areas, it's worth having, we think, an overarching vision and providing some engagement to set some direction by policymakers. There are lots of stakeholders who need to be involved. There are government policymakers from many different departments. There are utilities, of course, standardisation organisations, manufacturers, and different parts of the supply chain that need to be engaged, and preferably to set out a path forward or a roadmap as to how policies can be rolled out to address these kinds of barriers. So having an overarching vision and engagement strategy is important. And back to those three barriers. The first one, consumer perceptions. Addressing consumer sort of distrust or disbelief in the benefits. Having standards and methodology that can first of all measure those benefits and then provide to consumers transparent and comparable info would be useful. And one example is the Energy Star program now has a specification for smart home energy management systems where the Energy Star logo can go onto a complying smart home energy management system or smart thermostat effectively. And that's one way of having an independently verified promise of benefits. Also, consumer promotion and labels. Of course, Energy Star is, of course, a label, but there are others. In Germany, there's a smart grid ready heat pumps label. And in Australia, the yellow graphic on the right there is from a label that's applied to demand response ready appliances and air conditioners. There are some examples of consumer promotion and labels. Also, making sure that privacy policies are clearly stated and understood by consumers would be helpful, and also aiding in the development of security standards would help to give consumers some comfort also. Next slide, please. Addressing complexity and technology risk, demonstration projects promoting open protocols which can ensure interoperability between devices would be helpful. It's also good to be transparent with consumers about the issues, the solutions, and the results. Next slide, please. And the final one in the addressing of the barriers. It's back to business models. Having business models which can create consumer subsidies, both to address the initial cost and ongoing participation, would be helpful. And also developing market regulations that can facilitate new business models. For example, in the demand flexibility space, allowing aggregators to come to the market and aggregate smart devices into very large aggregations that utilities can take advantage of easily. So developing those kinds of markets and regulations would help business models and the sector to flourish. So that's really a sort of look at what might be able to be done to help the uptake of these two important opportunities, one being intelligent efficiency, the other demand flexibility. There are also some nearer term opportunities that could be taken up, which perhaps don't require such long-term planning. And the first one is something we're studying here at Edna, which we call Smart Ready. And it's based on the premise that if I buy a white good today, an appliance or a water heater or an air conditioner, it's going to last 10, 15, 20 years. And if it's not ready to participate in a demand response or intelligent efficiency ecosystem, then it's going to be locked out of that for many years. So making devices smart ready today, even though the kinds of ecosystems may not exist yet, but they may exist, in 5 or 10 years. So having them ready now, we think, is a good idea. So we're sort of looking at that issue right now. Also, another opportunity we're going to take a look at is efficiency is not always a key focus of smart devices. You might recall I had a slide previously of a toothbrush, a smart toothbrush, and it's not a device, a smart toothbrush which is connected to your iPhone and uses an app, doesn't of course really have an energy saving component to it. So there's lots of smart devices being developed which focus on comfort and convenience, security and safety and so on, all those kinds of benefits consumers like, but energy efficiency is sometimes overlooked. And I have an example of that I bought a number of motion sensors to install in my house, and I learned pretty quickly that these motion sensors, if motion was detected, they were able to turn on devices around my home. They could turn on the lights or turn on the air conditioning system if there was motion in the room, but they didn't have a feature for if there was no motion detected for a period of time, turning off a device. And I thought that was a very easy and sort of overlooked benefit. They would turn devices on, but they couldn't be used to turn devices off. So I think what was overlooked there was energy saving. And I think, we have a hunch in Edna that's the case for other kinds of devices as well. The energy efficiency or energy savings is sometimes overlooked when devices, especially first generation devices, smart devices, are brought to the marketplace. And the other one is, and we published a report on this, which is devices can be made energy aware. What that means is devices can pretty easily estimate their own power consumption or even measure their own power consumption and report that to the consumer. And this is something that can be done quite readily to give the consumer and maybe third parties access to real-time energy use information, often estimated, which is very easy to do, and it's just a software that can build into devices. So there's a few things that probably can be looked at pretty quickly, especially at the sort of device level, which is where Edna operates. So, in summary, connected devices really are at the coalface of energy use. They're at the end of the line, the end of the electricity distribution network. They're at the edge, if you like, of the communications network. They can save energy and they can provide demand flexibility, but they do use energy to connect. The opportunities are significant to save energy, but policies and standardisation are required to increase consumer confidence, to facilitate business models, and to ensure minimal energy is used to connect. So, thank you. That's my presentation. There are a number of ways you can get in touch with Edna or myself. The email address is there, the Edna website. There's a link there to the Edna Publications Library, and there's also a link back to the IEA's resources on digitalisation of the energy system. I know Vita's already mentioned to you the next webinar that's coming up, Light Bulbs or Cables. That's happening on the 25th of September. And now I'd like to invite you to ask any questions, and Vita will in turn ask those questions to me.
Thank you very much, Steve, for this insight into the role that connected devices are already playing and will continue to play, and on the importance of policy making in this context. I'd like to urge all our listeners to take the opportunity to look at the Edna website and the publications. There's some fantastic resources, as well as to also look at the IEA library and resources on digitalization for energy efficiency. Before moving on to the questions and answers session, just a quick reminder, please do ask questions and use the attendee interface in the question box. So Steve, we're starting to get in quite a number of interesting and challenging questions for you. So I hope you're ready.
Yes.
Excellent. So one question that we've received is regarding the energy use of connected devices and networks, what is the next step for the IEA G20 Connected Devices Alliance? So maybe start off by telling us what this alliance is and what it's planning to do.
Sure. A very sort of related initiative to Edna is the Connected Devices Alliance, and this was a product of the G20 back in 2015, who challenged G20 members to address the issue of the energy used by connected devices. And from this sprang the idea that, well, we really need industry and governments to talk together to develop policies in this area. So the Connected Devices Alliance is a platform of 350 or more now people from government side and from industry side and academia and NGOs who get together to talk about connected device energy use and the opportunities for saving energy and for providing demand side flexibility. So the Alliance has developed its really flagship initiative is a set of principles for connected devices. So, in fact, if you go to the Edna website, you'll see a link back to the CDA's website, and on that website, you'll see what we talk about there, the principles for energy efficient connected devices, which talks about how connected devices, the kinds of things that need to be thought about when designing connected devices, so they save energy, and also talks about a set of policy principles for governments, particularly when they're developing policy for connected devices. So that's really, a starting point. And there are a number of organisations, I think 15 in total, governments and large manufacturers and industry associations that have taken up those principles and pledged to adhere to them when designing devices to save energy, and also when designing policy. That's really our flagship. And we also have a publications library, which has a number of curated publications, white papers and policy papers on these issues. So I encourage you to have a look at that. You can also, if you Google Connected Devices Alliance, you'll find the website also. But so we continue to work on those things and promote those two initiatives. But we're always hungry for more ideas, particularly from the industry side, as to what further initiatives could be undertaken between government and industry.
Excellent. Thank you, Steve. So another question. What could you tell us about energy harvesting, and is that something that could help connected devices offset their standby power consumption?
Sure. Well, there has been some talk of, and well, firstly, to explain what energy harvesting is. Energy harvesting is harvesting ambient energy on a very small scale, at the device sort of scale, harvesting heat or light or vibration or radio waves even, and converting that to electricity to power devices. And there are examples now that exist of particularly small sensors and things that use energy harvesting to power their devices themselves. So they don't need batteries and they don't need a mains connection. They're self-powered devices. And there has been talk of using energy harvesting to power the network standby function of devices. So for example, the light globe example that I used, where the light globe sits there and uses power even when it's off, to have that power provided by an energy harvesting technology provided by ambient light or heat from the environment would eliminate and alleviate that ongoing 24 hours a day energy use for connectivity. So that's one thing we're looking at Edna. It's an expensive option at the moment, but sort of looking at ways that that might be accelerated, so that the energy cost of connectivity for devices might one day become zero.
Thank you, Steve. So moving back to the energy savings benefit, we have a comment here that the energy savings benefits of connected devices are routinely overlooked in the cost-benefit analysis of proposed energy efficiency regulations. And the question is, how do you remedy this? This is, of course, a very broad and complex issue, but do you have any ideas and any tips for policymakers from your perspective?
Look, I think that what's talked about often is the potential, and I've talked about it, of course, in my presentation, the potential for connected devices to save energy, and the potential is very large, absolutely. But the uptake and the realisation of that potential, there's some way to go to do that, and that's a lot about what we were talking about today, was how can we address those barriers and turn that potential into reality. And also the other thing to mention there is it's very hard to measure. It is actually hard to measure the benefits of the actual energy savings from intelligent efficiency. So having ways of measuring those savings would be a very useful first start. How do we, how can we agree that, what those savings are? Not just the potential, but the actual savings that can be realised. It's actually quite difficult to do. So I think that'll probably be the first step in trying to quantify and sort of balance out that cost-benefit equation.
Thank you, Steve. And in the presentation, you mentioned the issue of interoperability, or rather the lack of interoperability. Can you share with us some insights on why devices aren't interoperable and what we can do to move forward in this area?
Yeah, I think, I mean, my personal experience of this is that it is, I think, fairly common for device manufacturers to want to wrap up their devices in an ecosystem of their choosing, a sort of a closed ecosystem. So, in other words, if I buy products from brand X, I can't use the app from brand Y to control them. I need an app on my phone for each of the brands in my house. So having some sort of way of addressing that, would be useful. It's a commercially a very difficult one, I think, because it is in the commercial interest of manufacturers to wrap up devices in their own ecosystem. I understand that, and that's a commercial driver for investment. And having open protocols is not always the best way for manufacturers of devices to sort of take market share. So it is a very difficult problem, actually. And while open source protocols, I think, often seem to be the answer, it's what we don't want to do is sort of stifle innovation by having people not investing in these kinds of intelligence systems because they don't like the openness of them. So it's my sort of personal slant on it, but be curious to hear what others think as well.
Well, following up on that, we do have a comment in question that assessments on risks for competition and how to address the benefit of consumers for enhanced interoperability would be an area that would warrant further attention. Any views on that, Steve?
Yeah, I think so. I mean, it's before I came to this topic, I always thought that open protocols are, of course, the best solution. But I think that's still the case. But then, presented this argument of, well, if that's going to stifle innovation and investment, then okay, that's probably not the answer. So I think I don't pretend to be an expert in this area, but I certainly have a view that it's quite a difficult problem to solve.
Excellent, thank you. Well, we'll add that to our list of areas that warrant further attention. Moving back to the benefits of smart devices, we had a question around energy poverty. So how can connected devices be accessible to people affected by energy poverty in order to deliver energy savings? And have you heard of any initiatives in this direction?
I haven't personally heard of any, not to say that there aren't some. I mean, I think anything, which saves energy in an energy poverty situation is a good thing. Of course, we don't want, to burden these households with additional costs. So I think, to have subsidies in this area that will help households experiencing energy poverty to access these kinds of technologies, I think would be a good thing. And also, I suppose it's worth noting that that connected devices, don't necessarily cost that much more. For example, with a large appliance, it's not particularly expensive to add a sort of communications module to that appliance or air conditioner and so on. It's much different for a light globe, but for the larger the appliances, the less of a cost impulse it is to make that device connected. So, but there still will always be some cost associated with having smart devices, and it would be nice if someone other than the household could bear that cost.
Thanks, Steve. So we have a comment here on an update. The Energy Star program has just published a Smart Home Energy Management Systems SHEMS. The program is the first ever system focused as opposed to product focused specification. And the question is if you see this as a step in the right direction regarding connected devices. So focusing more on systems rather than individual devices.
I think so. I mean, I mentioned that exact Energy Star specification in my presentation. So I think it's an excellent example, and I know that Energy Star people worked very hard for a long time to try and solve some of the challenges of, a specification for a system and being able to measure the benefits in order to apply the Energy Star logo. Look, I think it's excellent and highly commended. It's I think a shining example of the kind of policy thinking that can go into this whole issue.
No, thanks, Steve. So we already mentioned or discussed briefly energy harvesting, but just looking at the types of devices that are currently out there, and mobile devices use very little power for network communications. Do you have any sense of why this technology isn't also used in mains powered devices, and what would be needed for a greater uptake?
Sure. Look, I mean, I think the obvious answer here is that mobile devices are battery powered, and to increase the longevity or the life of that battery is a big driver, for device manufacturers. And take the smartphone as a great example. I mean, they spend smartphone manufacturers spend, I would guess, billions of dollars on R&D into how can we improve that battery life. So they design the whole device, the whole phone, around saving energy to increase the battery life, and they have lots of budget to do that, and a big incentive to do that being the battery. So it's not so much the case for a device which plugs into a main socket. Of course, there is no imperative there to save energy. So that whole paradigm of reducing network energy use doesn't exist. And how do we get that paradigm from battery powered devices into mains powered devices is again a difficult one. It is a paradigm shift, but I think the good news is that the communications protocols that battery powered devices use, and they use the same protocols that we use in mains powered devices, Wi-Fi and Bluetooth and Zigbee and those kinds of things. Within those protocols, there are options that can be taken up by device manufacturers. There are energy saving features that can be adopted and used to really reduce energy consumption. So I think a simple step in that direction is to at least choose some of the energy saving options within the communications protocols as a first step. You do run into some problems with latency and so on and performance, but I think there is, from what we studied in EDNA, there is some potential to start to reduce network energy use just by taking up some of the energy saving options within communications protocols.
Thanks, Steve. And we're getting in a lot of interesting and exciting questions, so we're jumping a bit from topic to topic. But back to policy approaches and the role of industry. We have a question of industry-led voluntary agreements and what role they could play in addressing energy efficiency in complex connected devices and equipment. Do you have any insights on what this role could be and the importance of engaging industry in voluntary agreements or encouraging industry to take the lead on voluntary agreements?
I mean, there are, of course, several
maybe,
examples.
Steve, before we start, sorry, what are voluntary agreements?
Oh, okay. There are quite a number of examples of voluntary agreements where the government chooses not to regulate, but the industry steps forward and says we will self-regulate by using a voluntary agreement, so that the manufacturers get together and agree on the kinds of products they will manufacture, and the government doesn't introduce a regulation. And there are is particularly in sort of electronics. There are a number of examples of those voluntary agreements. I think there are also, people studying the efficacy of those. I don't again pretend to be an expert in whether those are, are better or worse than regulations. I think that really is up to the policymaker themselves. So, in terms of the technologies, again, it's not clear to me whether one's better than the other, but I think. This time, any and all policies, should be on the table.
Thanks, Steve. Just to add on to that, if anyone's interested in examples of voluntary agreements, there are agreements on set-top boxes and small network equipment in the US and Canada that have published some reports and assessments on the impact. So that might be interesting to look into. Moving along, we have another challenging question. Is there a way, Steve, to make existing devices smart and connected? The question is raised particularly in the context of developing and emerging economies where people might find it challenging to replace existing devices.
Yeah, look, I think that the simplest solution there is a smart plug. So this is a plug that you can plug into a general purpose power outlet, a general purpose socket, and you then plug into that smart plug the appliance. So it will essentially, and the smart plug is connected to communications network. You can control it using a smartphone or some other kind of remote system. So it effectively gives you on-off control of whatever's plugged into that smart plug. So that's, and these days they're not particularly expensive. So that's, it's a fairly crude device. It just gives you on-off control. But I mean, that would have its place with switching on and off a water heater, possibly, a simple heater or simple air conditioner or light globe. I think there'd be lots of applications where that would work and would save the cost of buying a whole new appliance.
Just to add on to that, in the area of demand response, in theory, it is possible also to make existing, say, air conditioners demand response enabled, but the cost of it is much higher than if you were to introduce that capability during the design stage. So to make something demand response enabled, something that's already deployed in, say, residential households, you need an electrician and you need to add additional equipment to the air conditioner, so at a much higher cost.
Yeah, and I talked a bit about making equipment and appliances smart ready. So as they leave the production line, they have within them a little control module and perhaps a little communications module that's inbuilt, so they're ready. So all the hopefully all the consumer has to do is just plug something into them or connect their phone to them rather than requiring an electrician. So to have all appliances and devices smart ready, or at least the sort of larger ones, I think would be a good goal to aim for.
Thanks, Steve. And so we're nearing the end of the webinar, but we do have an additional question around demand response. And if you could just elaborate a bit more on the incentives for utilities to encourage the use of connected response devices.
Sure. I think in many cases this will come down to the kind of regulatory environment the utility exists in. If they exist in an environment where the regulator requires them to do some kind of demand response, often that's the case, or at least requires them to compare the cost of demand response versus the cost of building new, for example, transmission lines. I think that's again, I'm not an expert in utility sort of regulations, but my feeling is that having the regulations in place that incentivize utilities to undertake these kinds of activities is helpful.
Thank you, Steve. So we've had a very active group of participants for this webinar, and we've received far more questions than we have time to answer at this stage. But we will have a detailed look at all the questions and all the comments and all the suggestions. And I think it's very indicative that there's been a great interest in this webinar, and that, Steve, you've managed to spark off a great deal of curiosity and managed to cover a lot, but also managed to raise a whole host of new questions. So we at the IEA will definitely look into how we can develop further webinars to share experiences and insights in this topic and in the wider topic of digitalization for energy efficiency. And just to mention again, we do have a few questions from the group listening in. The webinar will be available online in a few days, and we will send out a link to all registered participants, and you're of course more than welcome to share with your colleagues and friends. And with that, I'd like to say a huge thanks to Steve that's borne with us and given us some excellent insights, and been able to answer a whole host of a wide range of very different topics, from policy to technology related to systems related. So great thanks to Steve, and a big thank you to the group listening in and participating actively. And we look forward to meeting you again on our webinar on the 25th of September. Thank you.
Thank you, Vida.